So, hello students, welcome to this session. This is a mock interview session of one of my student registered for the interview guidance. He has cleared his he has cleared his DRDO requirements. All set to be selected there for DRDO after this interview. So, Tushar, congrats first of all,
Thank you,
and
sir.
congrats for being selected for that coveted interview. So,
Thank you, sir.
introduce about yourself.
Sir, myself, Tushar, sir, I am from Delhi. I did my class 10th and class 12th from Vishwabharati Public School, Dwarka, Sector 6. After my 12th, sir, I did my B.Tech from UPTU, from ECE Trade. And after my B.Tech, after 2020, after my B.Tech, I joined Samsung as Senior Assistant Engineer in R&D branch. And sir, I left my job in 2022 Jan for my GATE and government service preparations.
So leaving Samsung is a big thing. It's a big deal.
Yeah.
So how did you face that? I mean,
Actually, sir, when COVID came, sir, yeah, it was a very bad time for many one. But sir, it sir actually sir proves sir a good time for me, sir. Like I was in plant, and sir, we have worked from home for three months, and sir, a plant engineer has a free time at work. Like the robots can't be at your home, you can't operate them from your home. So that 3 months, sir, I studied, and sir, then I felt that yes, I can do like GATE or any of the examination. I sir gave sir BARC exam that time, sir, only just 1 month prep, and sir, I was just left out by 0.5 marks.
oh,
My section. Though sir,
very
that time,
close.
sir, I thought that sir, if I do my this thing for 1 year, my time, I can really do good. So that 3 months, sir, made me realize. Then sir, I left my job.
BRC is completely an interview-based
Yes,
selection.
sir. Yes, sir.
What is critical is completely the interview is very critical there.
Yes, sir.
So yeah. Tell me, how did you get selected for this DRDO interview? What basis you have been selected on? The GATE
Yeah,
score or
sir.
exam or
Yeah.
what's the basis?
Sir, DRDO has sir three phases. Sir, the first one is sir pre cutoff is based on gate that. Sir, I gave gate in 2021. That time, sir, my rank was 4,500. Like one month study.
Okay.
So, sir, somehow I don't know, sir. I cleared my pre. That time DRDO cutoff was 441, and sir, my gate score was 442.
Okay. 1 mark
Then
ahead of it?
yes, sir. I
Again.
don't know, sir, how then, but sir, when pre came last year in November 12, that time, sir, I was full prepared, like 1 year
Okay.
complete study.
Okay.
And then, sir, mains, I gave mains. There were two mains one and mains two, same on ESC pattern. And then, sir, I qualified at mains, and I scored a very good marks. I don't know the marks, but I am
So
very
your DRDO
sure.
is through GATE score now.
No, first pre is through gate score. Then, sir, they have a mains two
Okay.
exam based on
Okay. You have
UPSC
cleared
pattern.
both of them. Fine.
Yeah, mains one and mains two.
Okay.
Subjective paper.
Okay.
After that, the
That's
interview is on 12th.
that's a really long process, and really, I appreciate you. I've seen you since last 1 2 years. The dedication that you got, the way you
Yeah.
prepare,
And
that's really awesome. So
and
shall
sir,
we
the
start?
best part is sir,
Yeah.
and sir, the best part is sir, that the gate score is only qualifying. They don't count gate score.
Yeah, of course.
They count only mains and interview score.
Okay.
So that 441, 442 is just a luck for me.
Yeah, obviously.
Yes, sir.
So you've been a student, so you've been a student been very dedicated for these competitive exams. I've seen your approach learning from multiple teachers. Frankly, you have to learn from multiple teachers, multiple institutes now. That is the situation. No
Yeah,
single
yeah,
institute can give you all the inputs. Maybe they fail in one or two subjects, then you have to go to some other teacher, some other institutes. So that approach of yours always appreciated. Going for multiple teachers and getting the right content. So shall we start the technical part of the interview?
yes, sir. Yes, sir.
My first question is, supposing you have been selected in ISRO also in a similar manner,
Yes,
in a
sir.
similar position or similar pay scale,
Yes, sir.
and you are selected in DRDO also,
Yes, sir.
which one you would prefer?
So for me, sir, both are the like best prestigious organization of this country. If I have to choose, sir, like first of all, sir, both are same. There is no conflict that I would be lucky enough if I get any one of them. If sir, still I have to make a choice, sir, I will go for DRDO
Wow.
because sir, DRDO, sir, like promote you for your M.Tech also. like they allow you to
Exactly.
M.Tech. Second is the work in DRDO, sir, like being a young blood, sir, I generally like missiles, rocket, radars,
Quite inspirational.
drone. Yes, 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 sir.
Okay,
That's why.
fine. So this question, yeah, you've been more diplomatically answering towards DRDO. This is one doubt I always get personally myself. What should I answer? In fact, I asked this in mock interview for many students, and I could not give them a proper answer myself because it's very confusing. To be frank and
Yes,
tell
sir.
that I'll take my decision, or should I say diplomatically DRDO?
Yes,
So
sir.
it's a tough thing. So that's why I asked you this question. This will be
Okay.
fetching a lot for you. Maybe they will not directly say ISRO, but they say a better opportunity or something like that. Be prepared for this.
Yes, sir. Okay.
Can you describe your BTech project? What was your contribution and what did you do?
Okay. So my project was on smart medicine box. I will tell in brief, sir. Actually, sir, nowadays, sir, like we were four in team, and so one of my friend grandfathers sir died by taking irregular medicine. So sir,
Mhm.
that inspiration sir came from there. Like so, 20% of death in India are sir because of Alzheimer or irregular medicine, missing medicines. So sir, we design a smart medicine box using Arduino as a microcontroller. So basically, sir, that's we have sir four counters using RTC as a module and
Mhm.
Bluetooth. Sir, we gave a very and a 16 cross 2 LCD. Sir, we gave a very user-friendly interface
It's
in
a
which sir you
complete
can set up
hardware
a
project.
time.
It
Yeah,
was a
hardware
software,
plus software.
Arduino
Like sir,
programming.
yeah, like sir, coding was sir done by me only. Like sir, you have to set your medicine time, and sir, it has a safety feature also using a servo motor. It will sir only open when sir the time will come. There's a
Okay.
apart from that, sir, there is a emergency button also. But sir, like a very strict medicine schedule can be followed using that. Using your phone also, like sir, it will give a notification on your phone also that it's a time for medicine, or the medicine is going to be over, like counting the medicine also. So that's how sir,
Project
we get it.
project is worth a startup.
Yeah,
It's
sir.
really worth
Sir,
a
and
startup
sir,
and
it was
worth a
a
startup.
very costly. Yeah,
Yeah.
our sir college sir selected it, but sir, unfortunately, sir, COVID came and sir, we can't give our presentation. Everything was just like this only. Marks, marks, marks.
But don't leave that project. I mean, that
Yeah,
project
yeah.
will fetch you a lot. Even DRDO works in such similar things. They
Yes, sir.
also develop similar things. So it will really help you because your Arduino backdrop or your IoT backdrop will help you in DRDO. So that's don't
Yes,
leave.
sir.
Be in
Yes,
touch
sir.
with it because that's the latest technology happening thing.
Yes,
Okay.
sir.
So that was about your project and that was about your backdrop and how you have come to DRDO interview stage and those things. It's really, your presentation is quite good. The way you're putting
Thank you.
your points are absolutely. I mean, this is your second mock interview, and remember, first mock interview was very impressive. That is the reason we have come out with this.
Yes,
Your
sir.
first mock interview, especially on microwave, was awesome. None of
Yes,
the
sir.
students have taken up microwave, and you have taken up microwave as your subject. That was really awesome. So can I continue with a few more questions on microwave?
Yes, sir.
Okay. My first question on microwave is, which among all the oscillators that you know is the most powerful oscillator for microwave frequencies?
Sir, most powerful, sir, as per I have studied, sir, I will go with magnetron.
Superb. Any reason?
Sir, because sir, in magnetron, sir, we are using sir multiple cavities, and sir, every time, sir, it is a circular structure, cylindrical structure. In center, sir, we have electron source, and sir, it is covered by various cavities. And sir, each time, sir, the particles sir go with one cavity, then again they come back in a circular motion. So, sir, multiple time oscillation is done. That's why, sir, it's a very powerful
Sum of all these
oscillator.
outputs is taken.
Yes, 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 yes.
Okay, superb. What about a reflex klystron oscillator? What makes it weaker than the magnetron oscillations?
Sir, having only one cavity make it weaker, but sir, it can be used for generating cell quite low amplitude and frequency also oscillations.
So microwave induction microwave जो oven होती है ना, in
Mhm.
that what is used, which oscillator is used for microwave frequencies to be produced in the microwave oven?
Sir, in microwave oven, sir, I think sir, reflex klystron is only
No, it's magnetron. It's magnetron.
Oh, magnetron, yes sir.
What is a magnetron? Hoti hai? You can open it and see.
Yes.
Microwave oven needs
Yes, sir.
heat to be produced, na? So it needs high
Yes, sir.
power. So it's
Yes, sir,
absolutely magnetron.
Magnetron.
Okay. I have a satellite communication system,
Yes,
right?
sir.
Satellite communication system which needs to operate with telephone and TV channels and such things. What sort of an amplifier you prefer there for microwave frequencies?
In satellite communication, with TV frequencies, sir, I
Channels.
will. What, sir?
Channels, TV channels, multiple.
Yeah. TV channels, sir. Basically, sir, I think at that frequency, sir, we can use high frequency can be used. Sir, I will go with like.
Yeah.
I think, sir, at that frequency, the TV channels are generally used at low frequencies only. But sir, since it's a satellite communication, sir, we need a high power to cross the atmosphere.
Microwave. Pakka it's microwave amplifier. What microwave amplifier do you prefer?
Practically used, sir, I think, sir, magnetron can be used, but sir, I think, sir,
TWT.
yes, sir, TWT is used because of some wideband applications.
We discussed this in the last interview also. You came close to it. I was just able to. I was seeing whether you connect it or not.
TWT amplifier, yes, sir, because
you told this, sir, wideband amplifier, sir, it is used for slow wave structure. You told it. I told yes, it is used in communications, and then I left it. Today I just said satellite communications.
Yeah. Wideband,
Wideband. Right. Can you just briefly talk about DRDO's major achievements or major projects? Have any idea?
Yes, sir. As per sir, some of the projects, sir, I have came through. One is, sir, the bulletproof jacket that they are doing, and the second one is, sir, like, sir, recently, sir, we have seen that in the Russia-Ukraine war, Ukraine were using, sir, the Bakhtiar drones, which were their major cause of victory. So that drone was neutralized by Russia using a specific frequency blocking system or jammers. So, sir, DRDO is working on that, like a frequency jammer for different kind of drones, missile, and that's the is going through. Next is, sir, the high frequency radars they are doing. So these are some main I have come across. Sir.
They're majorly into this helicopter design and they're majorly into this missile designs. But these what you told are the most upcoming applications.
Yes, sir.
Most helicopters that they indigenously want to produce are from DRDO. Radars, of course, they work upon.
Jammers are
they're really fast.
Yes.
For me, see, what I felt was helicopters and those things were their achievement, but it's really vast. What you told are terrific examples, no doubt. Missiles are initial into missiles, ballistic missiles and all. So good. So coming back to communications, I mean, can I speak about communications? I mean, it's not in your favorite area, but still. But sometimes in interviews, they may not give you a chance for your favorite area.
Yes.
So you have any idea about what is Hilbert transform?
Yeah. Hilbert transform with a transfer function of 1/pi_t and frequency domain, it is minus j sigma signum omega function. So it basically, sir, do a plus minus pi/2 shift when frequency is greater than 0, and sir, plus pi/2 shift when frequency is less than 0.
But initially you said multiplying with 1/pi_t something. Can you connect that 1/pi_t to 90 degrees?
Yes, actually, sir, if we, I will tell you, sir, the mathematical approach.
Yes, exactly.
Sir, the Fourier transform of signum t is 2/j omega. But sir, when we take that in time domain, 1/pi_t, 1/pi_t, using the duality theorem, so 1/pi_t can be done in frequency domain.
Multiplying here is shifting there.
Yeah. Minus j signum omega.
So multiplying with pi_t or 1/pi_t in one domain or convolution results in the shifting in the other domain.
Yes.
So where do you think this Hilbert transform is majorly used?
Basically, sir, Hilbert transform is used in giving a phase shift. But sir, if we use about the practical applications, sir, generating of single sideband signals, like a carrier into MT plus for lower sideband and minus for upper sideband, then Hilbert transform of MT into 90-degree phase shift of carrier can be used to generate a single sideband, which is useful in saving transmitting power.
So 90 degrees phase shift when you do that can give you 180 degrees phase shift also.
Yes, sir.
And that 180 degrees phase shift is used in cancellation of signals.
Can you
So
remember? So
therefore it
that
is,
can use in saving
that
power
can
and
be used
transmission.
in all of them. That's super. Really, I went for Hilbert transform for that reason only. Okay, I'll ask you a very interesting question here. I'll write the Fourier expansion or the Fourier components, the frequency components of an AM signal.
Yes, sir.
Can you tell me the modulation index from that?
Yeah, sure, sir.
How?
If we take, sir, like a single, I am going for a single frequency MT. So sir, it's generally, sir, AM is, sir, MT into CT. But if we talk about, sir, practical AM, sir, we prefer, sir, mu to be less than 1. In that case, sir, we shift the signal by AC cos omega t, where, sir, AC is greater than AM. In that case, sir, the expression is, sir, AC cos omega t plus AC mu by t cos omega m plus omega ct plus AC mu by t cos omega m minus omega t. So this AC mu m by t, that's the lower frequency, and the upper frequency amplitude give the modulation index.
Superb. So you have the Fourier components in front of you, means you know the amplitudes of the sideband.
Amplitude. Yeah, and
That
sir, by
amplitude contains your modulation index because it is
comparing with
m into carrier amplitude by 2.
yes, sir.
M is modulation index.
Yes, sir.
Superb. So I think I can't grill you too much in communications now because you answered Fourier transform, Hilbert transform. So that should be a sufficiently good deal in communications. So let me get back to analog, your favorite subject, I think.
Yeah, analog and EDC.
Analog and EDC, right? My first question from analog, when you draw the small signal model of an JFET or even a MOSFET, how many components do you find ideally, and how many components you find with channel length modulation included?
Sir, ideally, sir, if we talk about MOSFET, sir, the internal R is infinite. So that part is open circuit at the input side. But at the output, sir, we have a voltage dependent current source, ideally. But sir,
Super.
if we talk practically, sir, then, sir, due to channel length, sir, the current ID is depending on VDS, that the drain voltage. So sir, there is a resistance also RDS, which is generally very high. But sir, it's in the model.
So one,
Parallel with the current source.
if it is ideal, if CLM is considered two components.
Two components, yes, sir.
The resistance parallel to the current source.
Yes, sir.
Non-ideal deviation.
Yes, sir.
Okay. Can you talk about transconductance and its formula for an MOSFET? Enhancement MOSFET, transconductance formula?
Yeah.
Can you write and show me?
Yeah, sure.
An expression for it.
Of transconductance.
Yeah.
So like it can be write in multiple ways.
Yeah.
I'm writing two of the ways. And you can check from that. So after it, sir, we can write in multiple ways also, sir, like this box.
Just can you hold it for 2 seconds? Okay.
Yes, sir.
Oh, great. Can you tell me from where did you derive this?
Sir, in saturation mode, sir, the current is ID is equal to Kn, where, sir, Kn is, sir, mu n Cux W by L into VGS minus VTH whole square. Ideally, this is, sir, for ideal case.
You differentiate it.
Yeah. And so, sir, transconduction is a change in output current with respect to change in input voltage. So, sir, after differentiating, sir, we get this. Sir, multiple ways it can be right, sir, after that, like taking VGS values and ID value.
What is its equivalent for a BJT? Transconductance in BJT, what does it become?
Transconductance in BJT. Yes, sir. Transconductance in BJT is, sir, IC upon VT.
No.
That's the correct.
Can you be more? No. See, I'm expecting if you say transconductance, it's a measure of controllability of the output on the input.
Yes, sir.
Right? How much the output is being modulated from the input. मतलब
Yes,
output कितनी बदल रही है input के साथ.
Yes, sir.
What is its equivalent in BJT similarly? BJT में transconductance नहीं होता है, कुछ और होता है. Something similar to it.
In BJT.
Yeah.
So BJT, sir, it's basically, sir, the change of output current with respect to temperature.
No. Controllability factor कौन सी है input में? Current है.
Current. Okay, sir.
So current gain.
BJT. Yes, sir. Yes, sir.
It's current
I thought
gain.
sir, the GM also there.
You got it?
Yes,
See, you are saying output current by input voltage.
yes, sir.
But in BJT, it is not voltage that controls, it's current. Na?
Current. Yes, sir.
So IC by IB,
I see
beta.
my. Yes, sir. Beta.
Now, talking about CB configuration, common
Yes.
base configuration of a BJT. Can you justify why its input impedance is very, very low?
Yeah. So common base amplifier is basically the input at the emitter side and output at the collector side. And if we see, sir, the input of the BGT from the collector end, sir, we'll get, sir, RE uh, resistance. That's, sir, alpha upon by GM, alpha upon GM. That values are very low. The input side is very low. And, sir, plus, sir, common base, sir, also act as a unity gain current amplifier. And, sir, the basic property of current amplifier is that, sir, input impedance is low and output is very high. Thirdly, sir, I can support my answer of common base. Mathematically, I can support, like I as told you, sir, that R is very
Alpha
small.
term that you have used.
Yeah,
But
yeah.
I think you can simply say common base may input is emitter and base now.
Yes, sir.
And in active region, it's mostly forward bias now.
Forward bias. Yes. Okay. Yes,
Emitter
so
base
that
is forward bias. So
yes, sir.
forward
That
bias diode ke across input impedance obviously should be small.
less. Yes, sir. Yes, sir.
That's why it is 25, 26 ohms
Yes,
HI.
sir. 25. Yeah.
That's
RE
why.
value. Yes, sir. 25.
So that's good. Good to see you, very expressive. And what I'm really impressed is the way you connect things. The way you're connecting is very impressive. So,
Yes,
right.
sir.
Let's get to the next question from EDC. I
Yes,
would
sir.
like to talk to you about EDC.
Yes, sir.
Can you tell me the Fermi level and its position for different doping conditions? Why do you think the
Yeah.
Fermi level is different for different doping conditions?
Yeah. Basically, sir, Fermi levels, sir, come from Fermi direct function. So that tell about the probability of electron at a specific energy level with respect to Fermi level. That's 1 upon 1 plus e power e minus ef by kt. In if we talk about, sir, intrinsic Fermi level, sir, it's an average value of the probability of electron. So, sir, it not lie in the center exactly, sir. It depend upon, sir, the energy density states, but, sir, it lie like near to center. But, sir, if we increase the doping, sir, the like in n-type semiconductor, there's, sir, one, sir, free charge particle electrons. So that's attached to nucleus. So, sir, it is not placed in the conduction band because, sir, its bond breaking energy is very less as compared to the bond breaking of the covalent bonding. So, sir, it is below the conduction band. So in that case, sir, the Fermi level is above that level at T is equal to 0 Kelvin, because, sir, at T is equal to 0, sir, the probability of electron below the band is 1 and above it is 0. But if we increase the temperature and after a certain temperature like 300 Kelvin, sir, the bond breaking become more dominant as compared to ionization. So at that temperature, sir, our semiconductor, sir, goes toward intrinsic property, and, sir, the Fermi level come down. Same in the case of p-type, sir, it is above the valence band, and as the temperature is increased, the bond breaking become dominant after 300 K or specifically at 600 Kelvin, and, sir, it goes up. If we talk about, sir, there is some cases when, sir, our semiconductor is degenerative, sir, where the like
Regenerative semiconductor.
number of electron or holes are greater than the effective density state. In that case, sir, it is inside the conduction band or valence band. And
This question was
specifically,
asked
sir,
in GATE 2022 also. Degenerate semiconductor.
yeah, 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 yeah.
This question was asked. So ultimately, Fermi level is the average of all these electron
Yes, yes,
energies.
yes, sir.
So it can be close to the conduction band. If there are more electrons, it can be close to the valence band. And moreover, it's very temperature sensitive.
Yes, sir.
No. You have answered even one question that I was about to ask you. That is, N-type or P-type, jo bhi ho, if you increase temperature, the Fermi level will shift ultimately to the center.
Yeah, because, sir, bond breaking, sir,
Bond breaking
become
and carrier
dominant.
concentration will increase and Ni
Yes,
will
sir.
increase. So it will ultimately come to the center.
Yes, sir.
Can you tell me what are the causes of minority carrier injection in any material? कोई भी material
Yeah.
में minority carrier injection किस वजह से होती है?
Basically, sir, the injection in, sir, is very much dominating because of bond breaking. So, sir, if we introduce a light source, it can be, sir, with respect to time or space, anything. So the bond breaking will be dominant. Or sir, in second case, sir, if we talk about sir the diffusion process, in that case also, sir, the magnetic edges are very are introduced in the semiconductors.
So junction is one reason.
Junction and light
in breaking of bonds by any other reason.
Yes, sir.
Okay. I'll ask you a small hypothetical question. One end I have a temperature. I have a semiconductor whose one end is at a higher temperature.
Okay.
The other end is at a lower temperature. Will you find diffusion?
One end at higher temperature and other end at lower temperature. And high temperature, low temperature. Sir, I guess, sir, no. Because, sir, might be, sir, there's a like charge are not uniform. But, sir, if we take the case, sir, like here we have more number of charge and, sir, here less. So, sir, if one electrons, sir, come from here to here, sir, it generate a positive charge here. And, sir, here it generate a negative charge. And, sir, there's a built-in field introduced, which would prevent, sir, the further diffusion. So, sir, end of the day, sir, there is no current. So
no, end of the day, it's ultimately stability.
Stability,
it's an equilibrium. You can say from the temperature increase on one side being at higher temperature, you find electrons and holes both being generated.
Yes, sir.
The other end also lower temperature, there are electrons and holes.
Yes,
so there is a concentration difference.
Yes, sir.
This concentration difference no doubt results in a diffusion.
But sir, due to built-in field is generated,
and afterwards it stops and then later it stops. But otherwise, yes, momentarily, there is a very minute diffusion.
Yes, sir.
That is because the mobility is also different.
Yes, sir.
Electron and hole mobility is different. So there is a minute diffusion.
Yes, sir.
So when you have a semiconductor at two different temperatures, you can get a minute diffusion. There's no doubt.
Yes, sir. Yes, sir.
So that's about your EDC and awareness on EDC. Can you answer what do you mean by continuity equation? In EDC, what is continuity equation?
In EDC, sir, continuity equation is generally stated that, sir, inside a volume, the amount of charge entering and the amount of charge leaving is conserved.
So can you tell me the conservation points which all are discussed in that conservation?
Yeah, sir, the generation rate, recombination rate, and sir, both and sir, the current densities.
Like entering current density, leaving current density, recombination with the distance, recombination with the time.
Yes, sir.
Generation, everything is discussed. So generation, recombination with distance and time, entering current, everything is discussed in one single equation. That's called as continuity equation.
Yes, sir.
Super. So your awareness is awesome about EDC, especially microwave, because microwave, nobody is learning microwave nowadays, especially because it's not in GATE and it's not even in ESC now. That's really awesome. So all the best, Tushar. We'll have 2 more mock interviews with you. Still, you are pending with 2 more mock interviews.
Thank you, sir.
So all the best. It's very impressive. Thank you.
Thank you, sir.
And yeah, that's about our student Tushar. He's into our course of interview guidance.
Yes.
So GatePro, Suresh VSR, always there with you. See you, students.
Thank you, sir.